Good afternoon, and thank you for joining us for verification and validation in Innoslate. My name is Elizabeth Steiner, and I will be the moderator for this webinar. Today, you'll be hearing from our resident and founder, Steve Dam. But first, let's go over some quick housekeeping. During the presentation, feel free to send us questions using the panel on the right. We will get those questions answered in the question and answer part of the webinar. You can also interact with us on LinkedIn through the Innoslate user group or through Twitter using the handle @Innoslate. The webinar is being recorded and we will make it available to you after the live presentation. So please be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Dr. Steve Dam. He'll be sharing with you various V&V techniques and some of Innoslate's built-in features to help support this area of the life cycle. Dr. Dam has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. He has also received an expert systems engineering professional certification from NCOSE. He continues to apply systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send Dr. Dam any questions through the LinkedIn user group or send him an email to steven.dam@secondations.com. Let's go ahead and get started.
Thanks, Elizabeth. Appreciate the intro and welcome everybody. So I recently did a Washington Metro area tutorial on this topic and spent 3 hours, and we actually didn't get much demonstration done in it. So I'm hoping to do a smaller set of this and get to the actual demonstration portions of it. So what we're going to do is talk about V&V in the early stages of the life cycle, why it's important to start thinking about V&V in the very front end, and what are the things we can do and apply in terms of verification and validation at the very beginning. So it'll move into that in the preparation for V&V, what are the things we need to do for that, and then applying the ontology, make sure we have the right ontology for V&V. And of course, what's a verifiable requirement, talk about the requirement side of it, and then all the way into the planning phase of the V&V as well. So, or just the early stages. So what is V&V? If you go Google it, which is always my favorite first thing to do now. I used to go just look up in my Funk and Wagnalls, but older people will remember that reference. But it basically gives you these two definitions, and you look at it, and except for the word truth in the first one and the second one, they're almost the same. So it's kind of funny because we've taken, at least for U.S. government work, some very specific meanings to these different definitions to distinguish between the two. So verification is usually meeting the specification level requirements. These are basically the solution-dependent requirements and making sure they're being satisfied. In other words, you've had a fairly detailed design. Have I met those design requirements and needs? And of course, making sure that the solution was built according to those agreed-upon requirements. Oftentimes, things change, and in reality, and you have to deal with that in the process. And hopefully, system engineering is keeping up with the changes as things go. And of course, we sometimes call that unit testing, or up to the developmental test and evaluation level, where you've got integrated units into a system. Customer, what did the customer really want? What were their needs? What were their expectations even? And are those being satisfied by the resulting system? And then, of course, that solution-independent requirements are supposed to be satisfied, right? Because theoretically, you started with a set of, very high-level, functional requirements that gave you the basic top-level needs being responded to, what they're trying to get done. And sometimes we call that the operational level requirements. So also, basically, those are performed at the enterprise or systems level. Again, you're looking at often systems of systems and even the interactions of the new system with the legacy systems that are already working. So the process, that validation, you're trying to make sure that it really is going to be accepted into the target environment, and so that it can be fielded and be an operational capability. So the frequent term in the DoD world is called operational test and evaluation, and that really fits to validation. So I like to look at the life cycle as a V. A lot of us use this model. Unfortunately, it's gotten some bad connotations because people think that timeline on the V, which is happening from left to right, has to be decades. It does not. You can do the same process in a short time frame. You could do it as an agile process. You could do it a whole bunch of different ways. The reason I like this definition of it, though, is it shows that you're starting, first of all, in a state of operations and maintenance and going to a future state which is different than operations and maintenance. And ultimately, you're going to do some form of demolition disposal of whatever that system is. So you want to be thinking through that whole time frame of what you're doing. And then the development cycle is going down the V. You're decomposing it into pieces that we could go off and buy or build. And so working with it that way, and then integrating those pieces back into the overall system that through test and evaluation to validate and verify that you actually met the requirements and it can be fielded. I have a process going down the V, which is a little different than the one we've used going up the V. And we'll see different pieces of those details as we go through today. If you want to see more depth of that, you can go to Amazon and pick up my book on DoD Architecture Framework. The processes are actually all in there and discussed in a lot more depth, at least the front-end processes, I should say, not the back-end ones so much. So this is that going down the V process, and again, a lot of you remembered 499B, we knew and loved it. We used this process for a number of years and still do. I find that it still is a good way to think about the problem because it's really a very agile process if you look at it. It has all these feedback loops and can be done very quickly. So the basic classical way to look at it is requirements analysis, functional analysis and allocation, and synthesis of the problem. And so that's okay, but in reality, you can start anywhere. And normally when I'm working architectures at that top level, I don't have a definitive set of requirements. I have a very high level customer need, like the one for the Global Hawk was $10 million flyway cost. That was the requirement. So that was the primary requirement that we were working to when we worked on that project. And so you have to go through and do quite a bit of functional analysis to understand, well, what really does that mean? What are the more detailed requirements that I need to think about that? How do I get to that? Obviously, it had to have all kinds of other capabilities. That wasn't the only real requirement. Or you could do reverse engineering where you're taking an existing system, trying to turn and say, how can I do this better? How can I do it differently? And you start with reverse engineering. So again, that's a very classic process. I think most of you are familiar with that. The other process you're probably not as familiar with is one I made up because I never saw a good one for going up the V. And so we created this one. Sort of looks like one. We've got the nacelles in the back there, the IV&V planning and the verification validation itself. The saucer section is design monitoring. That's the portion that you always want to have all the way through the process where you're looking at design, looking at changes, looking at problems that you might have encountered and that you have to adjust. And so hopefully you're taking that and adjusting that and giving it back up to the actual stakeholders so they're on board and keep them informed as to the changes and anything that happens along the way. And of course that middle box is integration itself. We're going to focus on the V&V bubble on the bottom right today as we get into that. But we're going to talk about what that process is, but we won't necessarily, that's not what the primary thing of looking at the early portion of V&V. So preparing for V&V, a lot of times people will say, well, what do you need in these early phases? So there are things, if you look for the question marks, that have to be done in that early portion to help support the activities on the right. For example, if I'm starting architecture development, I know ultimately I need to have this operationally tested. Well, one of the requirements I'm going to have is for a test facility of some sort, or a test range even, depending on what it is. If it's a weapons system or something like that, where I have to blow things up, I'm going to have to get a range. And so those ranges get booked years and years in advance. So if I don't track that and know that right up front, that I'm going to have to go do that, then I won't ever get that in time. So we can streamline that whole process by doing the test planning, the operational test evaluation planning, and transition planning in this architecture phase. I also am thinking about what's the operations maintenance, so I've got to think about training, I've got to think about SOPs, all those kinds of things that you need to develop as part of that. All that can be done and should be being done, at least initiated, in the architecture development phase. Oh, and don't forget demolition and disposal. A lot of people seem to, and that's another important part, of course, as you go through this. If you do that early in the architecture, obviously there's going to be a lot of work to do in that architecture phase. People are going to say, well, why are you taking so long to do this? I'm prepping for these other things to make sure when I give you good requirements that all those other things that you have to worry about through the entire life cycle are being taken care of. Plus, you'll get a really good handle on your life cycle costs if you do that, take that approach. Again, coming down the V, I'm doing system design, so I need to have my integration and test activities. Maybe my developmental test and evaluation occurs in that phase, and so I'm going to be looking at those. So again, I'm looking at that process, the Starship Enterprise process there, to make sure that I'm going to do the things I need to do in that phase correctly. So again, a lot of it's planning, but the planning is what's essential to be done up front. So what do we need for that? We need an ontology that includes verification and validation information. We need to make sure we're going to capture the right information as we go through the process. We also need verifiable requirements. Most of the time the requirements we get from the customers are, shall we say, difficult to work with. They are all over the map. Some are really detailed and specific to a specific thing. I want the iPhone, and I want to use my iPhone in the field. Great. I'm probably not going to be able to do that for a whole bunch of security reasons, for durability reasons, all kinds of other things like that. So I've got to think about what's the functionality of that, and then how do I verify that I gave that functionality to the customer. And of course, the V&V plan itself, what are those plans that you have to create to develop what you need in terms of your test plans and other activities. So to do any of these things, we have to really prepare for V&V. We need to conduct the V&V activities and, of course, report the results. So let's talk a little bit about the ontology first. We use something called the lifecycle modeling language. If you're not familiar with it, you can find it at lifecyclemodeling.org. There's an open specification for that language. It's an open standard that's available. The basic elements in it are the action, which gives you your functionality, the artifact, which is your documentation, assets, the physical activities, and of course there's a subset of that, a subclass of that called resource. Characteristics and measures, that's where you can capture your metrics. Connection is your physical connections like conduits, or your logical connections between things too. You can create logical relationships between things, logical connections between things. Cost, of course, is an explicit variable in this. Decisions as well. So you're getting some more of the programmatic kinds of information. Input-outputs are part of the functional model as well as the physical model. And of course, location, physical, orbital, and virtual. Risk is another explicit one that we use for programmatics principally, but it is a technical problem, so we do track technical risk. And then, of course, statements, and a subclass of that is requirements that has specific attributes associated with it, and time. So with that, we have space and time, location time is space and time, so we got that. We've got metrics, all the measurement parameters. We've got cost. So you can do cost, schedule, performance with this ontology across the entire life cycle. However, when we went to implement the full V&V capability we wanted for our new test center capability in Innoslate, we realized we needed to add another subclass to action called test case. It's really just a special subclass. It has a few extra attributes that we needed, that we wanted specifically to it, that we didn't want to put it in the general action class. So that's why it was. And again, it's for the specific thing we were doing. And one of the things that lifecycle modeling language says explicitly, it's the 80% solution. It's not meant to be the 100% solution. So you should be able to add to that ontology anytime you want to. And with Innoslate, we make that very easy to do with the schema editor we have. So you can work with that as you need to if you need to add other things. I will say be careful, because you don't want to make this schema too busy. It gets too cumbersome and too hard to work with. That's one of the purposes that the LML was developed for, was to try to give you an ontology that was a good, strong basis, but as simple as possible. And that's, of course, that balance is difficult. Here's that test case. Again, it represents the set of conditions utilized to determine whether the system works as intended. And so some of the additional attributes that were added were status, actual result, expected result, and setup. And these were kind of some fundamental things we decided were important to add to it. Okay, so that's the ontology. So what's a verifiable requirement? I think a lot of you know that. Again, if you remember that process coming down the V at the top right there, you see a little icon of it. And that first box was the requirements analysis process. So this is an expansion of that requirements analysis process in a very simple PowerPoint kind of diagrammatic approach. We actually use a more, when we actually are modeling the activities. But it kind of shows you the basic flow, starting with your source documents, your change requests, user needs, anything like that, any external interface databases. You now can decompose these things as requirements. You can identify critical issues. If you have a problem, if something that one of these requirements is going to cause difficulties, that you may want to have to go off and do some trade studies and resolve those issues with the customer. But ultimately, you also want to make sure the requirement is verifiable. That's one of the primary quality attributes of a good requirement. We have a number of others we use, but that's one of the critical ones. And of course, working that and working changes, if there are changes made, again, coordinating with the customer. Ultimately, from this, though, we want to produce a set of preliminary test requirements that can be used as the basis for all the testing activities at the other end of the V. As we go through doing more analysis, in parallel we're doing functional analysis. So as we start getting our functions or our physical model being built, we can then trace those requirements to the actions or assets or measurements, the actual metrics that we want to tie to. So all that starts building that integrated total model of the system. Another aspect in all our processes is we want to make sure risk is explicit and explicitly thought about, because risk is a technical problem. Identifying those risks is absolutely critical. Managing the risks is a management problem, but the risk identification occurs by the technical folks, the design engineers, the systems engineers who are doing this work. And of course, reviewing all those activities, all the statements, requirements, and risks with the customer, making sure they're happy, and ultimately updating our knowledge base, which we use Innoslate for. So what's the characteristic of a good requirement? I mentioned verifiable. That's sort of the middle one here, but there's all these other bullets you can see: correct, complete, clear, consistent, traceable, feasible. That's a tough one. Modular, and design. What design means is is the requirement specifying a solution? That's one of the biggest problems. Again, as I mentioned, the iPhone example, that's a very typical thing to have happen. Someone specifies for so many reasons, and of course can get you in trouble if you have competition requirements, as most people do in their contracting. So what makes a requirement verifiable? It really needs to be able to answer the following questions. Can a requirement be met? And of course, the mechanisms for that is analysis, demonstration, inspection, modeling and simulation, or testing. Those are the primary 5 things people usually use as saying, okay, those are the methods I'm going to use to verify the requirement. Another is, will the user accept the results? You know, that's a tough one. That's one of those things that you've got to work with your customer base, your stakeholder base, have them understand, will they accept what you're doing, and is that a reasonable verification requirement? Another thing to do is avoid words like excessive, sufficient, resistant, all. By the way, all is another one that gets you in trouble. You know, number of these other things to watch for it. What you're trying to do is make sure the requirement is quantifiable. You can actually measure it. Because if you can't measure it in some form, some way, it's going to be very difficult to prove that you actually met it. And of course, suitability can be quantified even. A lot of times people say, well, what is that? It's kind of how people feel. Well, I worked on operational test and evaluation at Affotech, and the folks there used psychologists to develop questionnaires so that the users could be then, after using the equipment, could be surveyed to determine activity to do that and to get good results. So, but you can ultimately quantify those kinds of parameters as well. So instead of doing a demo at the end, I'm going to do something a little different than we normally do. I've got several of these demos kind of portions throughout the presentation. So actually, hopefully this will make it a little more interesting to you too, and by breaking things up. So here's that process again for requirements. So a couple things, I've got a sample project we've already done a lot of work on, and to give you an idea of how things can work. And so I want to look at some of the analyzed requirements for quality and derived verification requirements. So let me do that. Bring that up. You don't need to see my calendar. So we have a demo we call the FireSat Complete Demo. FireSat is a notional system that's in a whole variety of books. There's a series by McGraw-Hill, and one of the books that I'm looking at right now, in fact, is called Applied Space Systems Engineering. And so this system is discussed in more detail there if you want to know more about it. The FireSat idea is to have a satellite system that can help control wildfires in terms of being able to detect the wildfire and then cue the firefighting crews as to where to go and how best to accomplish the mission. So the first thing we said was about requirements, analyzing requirements quality. So here's an example in our requirements view, and this is some of the mission needs statement that again is from that book. And you can see that different amounts of it have different quality scores here on the right. What we did to do that is we have a quality checking tool. It's a little button up here that says quality check, and of course the rollover shows run quality checker. And so what that does is it goes through the different quality parameters and reads the actual description, and using natural language processing goes through it and makes judgment calls on, is it clear, complete, consistent, correct, and on down. And by the way, you can add other checks if you wish to this. It looks like this has happened on a previous demo. And of course, you can just change them right here on the sidebar. Now, if you don't remember these definitions, if you go with the entity view of an entity, it actually will show you the definitions as well. But we just saw the definition on the previous slide. This gives you an example of complete having been run and seeing that it didn't end with a period. It doesn't seem to specify anything. There's no verb phrase. So again, you have to look at it and say, well, is that written correctly? And it really isn't. I mean, there's no shall in it. There's some of the fundamental things you normally have in a good requirement just aren't there. That's why it's got a pretty low score. But if you decide, well, it's good enough, it's correct, it's feasible, it certainly is traceable. Okay, and then all I do is click the green check mark, and it'll bring up its score. And so that's a very quick way to do the analysis and make sure you're doing good analysis of the requirements as you go. By the way, it does not check when it's got just a title. So this is satellite uptime, for example, is here, and there's nothing here. It's all 0 because it doesn't really have anything to look at for the description field. So make sure you put a good description of what that requirement is, as opposed to just a simple statement or sentence in the name field. By the way, notice you could also comment on this at the same time. If you say need to add requirement statement. And that posts the comment, and then that can be then dealt with. So that's another feature of the tool is we allow reviewers to comment and be able to act in a read-only mode, and they can add these comments, and you can then adjudicate comments as you go through as well. So that's also part of verification, right? You're making sure that the requirements themselves have been verified and are correct. So this is a mechanism for doing that as well. So the second thing was deriving verification requirements. I was pretty fortunate that the actual book also contains a whole series of verification requirements. So I went ahead and captured those in here. And so one of the big ones is the space vehicle first mode natural frequency. That's making sure that it can handle the vibration of launch, because if it doesn't meet this requirement, it will basically could blow up on launch, and that's usually mission end, right? So obviously you're looking for things like that throughout here. We're going to show later how we've traced these as a trace to relationship, verified by relationship is available, and in fact, if we want to see what those have been related to, one of the quick ways is to open the entity view, and then we can see the trace to relationship here. And if we want to, we can see with the Alt tab the verified by relationship as well. So, by the way, you can through the schema editor go ahead and put verified by as one of your popular relationships. So you can move that up here so you can see if you're looking for those in general. Okay, so I think that's the main things I wanted to show with this. So let's go back up to the next phase of this. Okay, so the next thing was developing a V&V plan using model-based systems engineering. So the V&V process, again, we have to understand it and know what that process is, about verifying the requirements, are there deficiencies, looking at those deficiencies, looking at your risk plan, performing regression testing. It's funny, we call it regression testing in software. There is the hardware equivalent of regression testing, really. You always are trying to see more and more what works, what doesn't work, how does it fail. And of course, then coming up with deployment plans, any beta testing, and of course, reviewing the results with your engineering review board as well. So that's just the overall process. So the first step is go ahead and create a test plan. There's a in our documents view under the menu, you can select test plans, and then there's a couple questions. You can use the template we have, or you can create your own from scratch if you wish. Or if you have already done this before, you could have as a separate project. You could upload that XML output from Innoslate into your project and use that as your basic test plan. And then, of course, fill in the results. Now, that sounds like, gee, why didn't I just do that in Word? I'm sorry. The wrong thing. But it turns out that there's some real value, I'll show you in a second, of doing it within the tool. So for that part of the demo, I'm going to show you the actual test plan in Documents view that we've got working. I'll also discuss some of the techniques to use to complete the test plan, and then I'm going to show some relationships between the test plan and elements and the design. Okay, so back to the demo portion. And I left it up so it would be easy to get to. But to get to it was just simply menu, test plans. And it's right there and available, and it would pop up with this is the only test plan I have at the moment. If you have multiple test documents, you can manage those here and work with them. But this is just a Fireside acceptance test plan. I started with the template that we have as a basis. It gives you a version history chart to begin to fill in, introduction, and you start filling those things in, the purpose, things like that. Now, ultimately we come to test issues and risks. Now, one of the things that we have in the tool also is that risk matrix. And so the ability to take your risks and capture that. This is actually a screenshot, an actual picture of that risk matrix. So this is a snapshot in time. I did not bring this in as a diagram. I'll show you that in a second doing that, but this is just an image. So it has the ability to have a caption and things like that. If I click into it this way, I can click on that diagram and you can see the change actual link. And once you have a link in here, so this is the caption was developed from that input right there. But once you have the link, I can then go to it by clicking on it. I'm sorry, let me get off that for a second. So by clicking on it, and it'll actually take me to that matrix. And there's the matrix. And if I click on the one I had captured in my screen capture, which was the focal plane technology risk, then that would be right here and available, and I can adjust it. I can move these around. I want to move it to high world, and it automatically changes the probability and consequence. See it working with it there. If I want to add a new risk, I would just come back over here, clicking off of it, and just drag a new risk on. Very simple to work with and update. Now, obviously, if I've captured it as a picture, it isn't automatically going to update in the document. You wouldn't expect it to. However, if you do have it as a diagram, and here's a diagram below here. By the way, it builds in tables, things like that for you as well. So here's a diagram. So I clicked on the diagram, it actually takes me to the diagram itself in the tool. If I make changes to this diagram, they will show up in the actual in the document itself. So again, you start seeing the value of doing that. Let me go back. The wrong button again here. To add a diagram or a link or image table, it's all right here in that plus button. So you can add those things right here. Very easy to work with. Again, it gives you a lot of the word processing things you're used to. Works very well. And in case you're wondering, what's the output? The output is basically, report is a Word document. So the basic document output is a docx Word document. So you can ultimately work with that. We've got some tabular outputs, and of course, we can export the document itself as an XML. So this is a place where if you create templates, you could create templates and put them out as a XML file that could be reused to other places. I hit that part. So, yeah. So let's move on. I think I hit most of the stuff in that. So the next step is to create a test process. So here's where you want to take your action diagrams. You're going to use those as your behavioral diagram to model the process itself, and then linking those back to the test plan. You also can make sure it works using the simulator. So let's take a look at that demo. It's just some test cases and building the model we built, an action diagram, show you the simulator, and also we'll show you some tracebacks as well. So let's do that. So one of the things is the new feature in the tool is something called Test Center. And that's available also out of the menu over here, right underneath that first general column is Test Center. I've got it pinned up to my dashboard right now, up to my menu bar, so I can work with it. This is a set of tests, again, I got from the book. I'm making this stuff up. However, I did make up this process, which is the HE tank, the helium tank inspection process. And so, again, I embedded that process in this right here, so I could work with it, use that as part of the process, and link it back to it. This also can then be taken back into that test plan that we developed as well. So even though you may not have done these tests yet, you can do a lot of that preliminary planning aspect of it. So here's the actual process itself. I think I've got it up here. Yeah, this process. Again, if I click on that, it will take me right to this. So what I did with this was actually take and put some decent timing information. So roughly how long is it going to take? I like using, for most human kinds of processes, a triangular distribution. So it's sort of a worst case, best case, best case, worst case, and then the average. And so that's a way to look at those. And so as I walk through the process, those times are associated with it. And I can run this. Well, I've also added resources. I've got the helium tank inspector and the actual transportation of the tank as two of the resources I could use. Obviously, you could put other resources in, and I just put these in notionally to give you an idea of what that might look like. So to simulate it, to see if this process works, and of course it's a very linear, simple process, but now I'm trying to say, well, how long is this going to take me? How many times do I have to do this? Those kinds of things might be factors. And of course, you can have a much more complex test processes that you're actually modeled here. So to get this discrete event simulator, just really go up that button, click on it. I want to add some resource graphs as well, and play it. And what this is going to do is step through that process, and it's doing it pretty fast. I probably should, let me try to go back and slow it down a little for you. Get my graphs back up. Save that. So I can change the settings. It's set up at 10,000 times the speed. Let's get something closer to real time. We'll do a 10x for now. And now it's stepping through the process. That's a little too slow, right? So if I want to speed it up, I just hit the speed button here, and I can speed up a little more than that. You start seeing it go. So this total time for this inspection is roughly 2.5 hours. You can see the inspector load. You see the Gantt chart. If I wanted to capture the cost, I could also capture the cost of this as well. So again, it can track all those kinds of parameters you worry about. This does a little bit of your program management planning as well, which of course is something you need in your test plan. You need to know what kind of test resources you're going to need, how much time is they going to take. So you can link that all together also within the tool. Something I haven't even tried yet, and I'll go back to, is the main model. Let's do this in Monte Carlo. It shouldn't be much of a problem given that there's this is initializing the simulation, and a few seconds to get started. Okay. Not sure what's going on with that. Try again. There we go. That's more normal. So it ran through 100 iterations of that process. Now I can kind of see an average time is about 2.16 hours, 2.1 hours, 2.2 hours, and standard deviation of about 7 minutes, 7, 8 minutes. Again, you see that your usage down here, and again, that was very simple because it was just a single person, time and cost. And you see how much time it took in each individual area for each individual inspection step. And then this distribution is showing you so the worst case is it could be as much as 2.45 hours, which is 2.5 hours. So that's not bad. I mean, that's not much of a distribution. So not much of a time difference. It could be a little bit less than 2 hours to do the entire process. So again, those are the kinds of things that can help you and work with the whole process side of it. Last but not least was traceability. They want to trace back the verification. So remember we had those verification requirements? And if you click on this, these are those original verification requirements. You can see the actual requirement here on the sidebar and all its activities. And by the way, here you are getting the rollover on the different attributes, what's clear, what's complete, things like that. If I clicked on the acceptance test itself, tells you about the acceptance test and has all its attributes associated with it as well. And here's where there's an intersection between them, means that this is where I've got a verified by relationship, which is what I used as my target relationship. So this is a very powerful matrix to help you understand your traceability. We've got some other ways of visualizing this information, the spider diagram, for example. But this has become one of the more useful diagrams, and easier to understand diagrams, and a nice thing to be able to present to your customers. So, I think I'm doing pretty well. I'll be able to leave some time for questions. Good. I tend to overrun these myself, my part of the talking. So again, using the test center, we can capture that. We can make that part of the test plan itself as well as capturing the ultimate results with it and linking it back to the requirements that I was just showing you. So some of the other things you can do in testing, you can model your test equipment and facilities, so you can capture that information. You can model the test organization, get roles and responsibilities, link those together. Again, risks I mentioned a little bit earlier, but you also do the mitigation techniques and capturing those. There's relationships to show what's the mitigation factors. Again, metrics that you're trying to capture and understand, a schedule. So this lets you get your scheduling information, your timelines. Work breakdown structure is also available through our cost entity. And again, data capture itself, you can capture the actual measures and times, and artifacts. If you actually have digital results, you want to capture pictures, other things like that could all be captured as artifacts and added to it. If the location's important for where is this test occurring, things like that, that's another parameter that's available. You can even put that against time to say at different times you have different locations you're going to be at. And decisions, of course, to capture what are the decisions that have been made, why they've been made, that kind of thing. So in summary, I think we covered looking at V&V in the early stages of the life cycle. We talked about preparing for V&V. We talked about the ontology, using LML to capture your V&V information. And of course, what's a verifiable requirement and developing a V&V plan. I think we've got about 15 minutes available for questions. So, Elizabeth, do we have any yet?
Thanks, Steve. We've actually received several questions already. If you haven't done so, please send your questions to the panel on the right. If we can't get to all of your questions, we will contact you after the webinar. All right, so for our first question, we have, can you have the comments seen on the main screen alongside rationale?
So yes, let me oops, better not do that. Just a second here. Okay, so if I have the rationale for something, let's see, V&V had rationale associated with it. So yeah, so here's the rationale, for example, in this. If I click on the item, here's the comments associated with it. So it's right here. So that's all available in the requirements view.
Just to add to that, Steve, sometimes people ask if you can have them on the right corner, right next to rationale, and the reason we don't have it designed that way is because the comments field is meant to be like a string of comments. So your requirements document would become clunky and too much to view at once. So that's why we designed it this way, so it's a little bit easier to view. So for our next question, what is the difference between trace and verified by?
Well, that's really up to you to a great extent. Usually the verified by means that those are the things that mechanisms for how I'm verifying the requirement. That's what I'm usually mean by. Tracing usually means, well, I could trace to an action that has to occur in a process. So that might be another way I do it. Or I'd trace it to something physical. I could do, for example, we often get a requirement in the Navy called paint it gray. And it's my favorite requirement. And the gray means a certain shade of gray, so it's very well specified. So you actually have to then link that to that specific piece of information of what that gray means. So it's things like that.
Our next question is, can I create a V&V plan for entities other than requirements, such as MOEs?
Well, yes, of course. In fact, MOEs are just the way we handle that in the database. MOEs are just in the measures class. I don't have any examples here in this particular one, but we could add one easily. And you can see the type of things that are in it. Value, projected value, threshold, objective. So now this lets you capture your metrics. You can then link those metrics to specific things as well in the plan. Yes, absolutely.
Our next question is, how can you save your own template and load it in the same way as yours?
Yes, so I mentioned that briefly. I probably was too fast. So I'm in here in this, so I build a template as I want it in Documents view. I can then export that, to report, as a document export file. That's XML output in our format for XML. So then that can be re-imported into any new project and be reused that way. If you already have a template in a Word format, then you'd use the import analyzer to bring it in. And that's here, import analyzer. That was also under the menu. I went too fast for you. Tools, import analyzer. That in, information in. If you've got it as an Excel format, we can bring it in that way. Or if you have plain text, we can bring it in that way. The reason we have these different options is when we import a document, we look at your numbering scheme So that gives you that hierarchy, which lets you have a more complete document. That's really important because then now I can do things like this. Reduce it down size. So it's a little more like an outlining tool capability as well. Okay, next question.
Our next question is, can you load a docx template with the company logo and formatting, font, paragraph, spacing, just taking into account for the template?
So yes, actually, again, that importer, the Word importer will pick up pictures and and information like that, and you can put that in. You can put any kind of picture in as well yourself. That's what this is. This is actually a picture. That's right here. Let me again click into this so you can see it. I click on it. It says image, change image, and that's a picture. So again, I can bring any images in and associate them with this. And so yes, you can do an awful lot with it. Now, we're not completely meaning to replace Microsoft Word as a word processor. You're still going to ultimately want to go to Word for your final publication. The idea, though, or the ideal here is to start getting people to start interacting right here within the model, within the tool, and never go to paper. That's what we're striving for in model-based systems engineering. The whole idea is to do model-based reviews. So now you never have to go outside the actual tool environment itself. So I actually, hopefully, don't need Microsoft Word anymore because of that, except as a full publication tool. And then I bring that in as an artifact into the database. And artifacts are here, and you can see the kind of information that we captured in an artifact. We can upload the actual document itself, information as well.
Can you write the next question?
Yeah.
It seems you are starting a project from the requirements, which is the very beginning of the project and the concept phase, and might not really work. Which approach would you be best in this case?
So it really just depends on where you are in the process. So as I said, when I do architecture work, very often I don't have a good set of requirements at all. I have to derive the requirements. I do that by doing functional analysis primarily to understand the operational processes that are currently going on and what I want to try to do. And so I come up with those processes, and from that I can derive the functional requirements that are needed and decompose those into the actual systems that perform those functional requirements. So yes, absolutely. Or if you already have like I said, if you have a well-developed system, you're very happy with it basically, but you know it's getting old, and I want to make sure I bring it up to date, I can reverse engineer that by starting with the physical architecture and working backwards through functional analysis up into requirements development. So that works for all those processes.
Can you share only specific parts of the model with reviewers? For example, only specific test cases, as you might not want them to see the whole model.
So one of the options in the tool is the ability to branch and fork. And so you may want to take a portion of it and create a branch and work with that way. That's probably your best bet. We designed the tool for collaboration purposes. So the idea is all the information, whatever project you share something with is meant to be shared with anybody who has access to that project. So again, if you want to partition the things into different pieces, you can do that by using the branching and forking mechanism.
Thanks, Steve. I'm afraid that's all we have time for today. If you still have questions, please reach out to us after the webinar. If we did not get to any of your questions, please let us know and we will contact you. We would like to thank you again for joining us today. As a reminder, we will be following up with you very soon to send you a link for the recording and the presentation slide deck. We would also like to invite you to our next webinar, Innoslate's Ontology, on July 6th. So be sure to check your email for the invitation. We also encourage you to visit our website as well as connect with us on social media. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar in July. Please enjoy the rest of your day.